Hello everyone, or really I guess just Miss Jensen, and welcome back to Michelle's version of calculus, where the longer she makes these videos, the more she feels like she doesn't understand. But it's okay, because hopefully you will. Alright, so today is 1.8, and we have the squeeze theorem today. Alrighty, and it's kind of, and squeeze theorem is kind of fun. It's kind of cool. Alright, so let me go down here. Let me draw us a little something to kind of help you guys understand this. So let's say we have a cute little graph here, and we have, let's say this one little function over here, we're going to call her g of x, and then we have another little function, and this function's name is h of x, all right? But, all right, so with squeeze theorem, basically, well, these technically shouldn't be touching, but it's fine. With the squeeze theorem, basically it's saying that in between g of x and h of x, there is another theorem, or sorry, not another theorem, I apologize, another function, which we'll call f of x, that is squeezed in between those functions. And it's kind of similar to how, like, let's say you have a cute little friend group, and let's say g of x and h of x are the more properly behaved functions usually, and they are keeping the more, I guess, disruptive function, or the kind of crazy friend in check, which is f of x, all right? It's kind of keeping it in that range and squeezing it to be there, all right? So let's I think this is like the official, I guess, kind of definition of the squeeze theorem, all right? So it says if g of x is, or so let's say if g of x is, pause, redo that. If f of x is greater than or equal to g of x and is less than or equal to h of x, and if the limit of g of x as x approaches a equals L, which is just a limit, value for limit, and the limit of h of x as x approaches the same a, important to realize, same a, equals the same L, these L's are the exact same L, same color, then the limit of f of x as x approaches a, once again, f of x for the function that's kind of squeezed in between those two is that same value also. All right, very important to understand. All right, so let's get into our cute little example here. Oh, actually our example's getting blocked out. There you go. All right, so let g and h be the functions defined by g of x, which is equal to cosine pi over 2x plus 2, and h of x is equal to x squared plus 3. If f is a function that satisfies, get a little handy dandy highlighter out, that satisfies, that's the wrong thing. And if f is a function that satisfies g of x is less than or equal to f of x, which is less than or equal to h of x, for this little interval here, for negative 5x5, what is the limit as x approaches 0 of f of x? Alrighty, so basically with this example, we're going to be we're going to find g of x first. We're going to find the lim. Let's switch this up. We are going to find the lim of g of x first as it approaches 0. Because based on our squeeze theorem here, that limit, if the limit of g of x is the same value as the limit of h of x, then that'll also be the limit of f of x. A bit of a tongue twister there, but do you keep with me? And that's going to be, so we have our lovely little original g of x function here, cosine pi over 2x plus 2, and we're going to take our lovely 2 here, or sorry, I apologize, and we're going to take our lovely 0 here, plug it in for x. So then we will now have, scoot down and skinny this up a little bit, cosine pi over 2 times 0 plus 2. And of course, anything times 0 equals 0. So let's pick a different color, green. So then we have, my bad. So now we're going to have a lim as x approaches 0 of cosine 0 plus 2. Alrighty, and cosine of 0, Hopefully you remember your lovely little unit pi circle. If you don't have it memorized, memorize it now. And the cosine at 0 is 1. So it's actually going to be 1. So that's the same thing as saying 1 plus 2. So the limit, I'm going to have to backtrack it backwards over here. So the limit is of g of x as x approaches 0 is going to be 3. Yep. All right, so now we're going to do the exact same thing, but for h of x. And I'm gonna go ahead and delete all this. It's okay, we have enough space in this corner down here. We will make it work. Let's make this tinier. All right, so now we're going to do the lim of h of x. So lim as x approaches, same 0, of h of x. So h of x here is x squared plus 3. And once again, these same colors are going to get that 0, plug it in for x in order to find our limit. All right, so 0 squared plus 3. Once you add that all up, you should have limit as x approaches 0 for h of x over here is going to be 3 also. And because h of x and g of x have the exact same limit value, which is 3, that means that the limit, let's do blue. The final answer will be in blue. That means that the limit as x approaches 0 of f of x, according to the Squeeze Theorem, should be 3. And that should be your final little answer there. And I know it looks very messy. I apologize, but it's important to note that there will be times where you won't be able to determine the limit of f of x because, once again, let's say in the scenario, let's say the limit of g of x was found and it was 5 and the limit of h of x was 7. This means that the limit of f of x will be somewhere between 5 and 7, but between 5 and 7 there are basically an infinite amount of numbers kind of between there, so it will not be able to be determined. So yeah, thank you for watching Unit 1.8.